So I will cover how to find roots in algebraic equation. Okay, so algebraic equation is like x square minus x minus 1 equal to 0, or x equal to sin x. So this kind of equations we can find roots x which satisfies this equation. Okay, so these are root finder or solution of algebraic equation. Okay, now so it's very important. I mean, you can see in fact I'm going to use it solve eigenvalues as well as solve the boundary value problems. Okay, I'm going to show it a little bit later in today's lecture only. Okay, so the idea is to solve this equation fx equal to 0. Okay, that's the idea. Now we'll cover quite a few methods. Bisection method is also called midpoint method. Okay, Newton's option, secant method, relaxation method, and Python's root finder. Okay, so this is here I will cover the algorithms, but here you can use one of the Python functions. Okay, bisection method. So this is my function. This black curve. Now it cuts fx equal to 0 here, right? I mean, this is at one point x, and I denote the root by x equal to x star. Okay, so root is denoted by x star. Here there's only one root, but this function can turn around and they can have another root. So we'll focus on only one root, but you can cover any roots. I mean, you can see that you start from in the neighborhood of the root, and you'll discover the root. Okay, so the idea for midpoint method is, or bisection method is, you start first, you make a plot. You need to know where the root is approximately. Then you choose one point to the left, I call it XL, and one point to the right, XR. Okay, so these are the points right of the root. So X star lies between XL and XR. L is left and R is right. Okay, now I know that it lies between the 2 points, between XL and XR. Now the idea is to compute the midpoint. So midpoint is, I have it here, XL plus XR by 2. Okay, so that's the midpoint. Now see whether the midpoint is to the left of X star or to the right of X star. Right now it happens to be to the left of X star. Okay, then what do? I replace this XL by this X midpoint XL. Okay, now the midpoint becomes new XL. After that, again I compute the midpoint. So I have XL, now new XL, which is XL, and XR. So midpoint will be somewhere here, right? It's somewhere here. Okay, so this is my new midpoint here. Now it is to the right. So what do? I knock off this XR and call this new XR. Okay. I'm basically getting closer and closer to the root. Okay, and that's how we get to the root. Okay, so in nth time step, we need to construct an algorithm. So we take the two values xn and xn minus 1 and take the average of it. Okay, and you have to knock off the one whose side xn plus 1 is. Okay, so if xn plus 1 is to the right, then you replace xr by xn plus 1, or if it is on the left, then xl will be replaced by xn plus 1. It becomes a new xl. Okay. Now, what about the error in this function? So error is defined as x star minus xn. Okay, at the present time, where is my guess value or my computed value by bisection method, and x star is a real value. Okay, so x star minus xn is a error. Now you can see how error is converging, or how the solution is converging, how error is decreasing with iteration. So how do I compute that? So you can just, in fact, you can use here x star. So I subtract both left hand side and right hand side by x from x star. So xn plus 1 equal to half. So this is going to be x star minus xn plus x star minus xn minus 1. Okay, sorry, so minus, of course. So you put a minus sign of this and put x star. Okay, so that's this what it is. Now this is error at the n plus 1th step, epsilon n plus 1, equal to half of epsilon n plus epsilon n minus 1. Okay, so error is definitely decreasing. Okay, so we can see that error is decreasing as function of steps. Okay, so this solution will always converge. It may be slow convergence, it's a linear convergence, so it is slow, but it is guaranteed to converge. Okay, so let's take an example. So I have taken the function to be log x minus 6 so equal to 0. Okay, that's what I want. So the solution is obvious. X is log 6. No, sorry, I made a mistake. It is not exponential. It is e to the power x. E to the power x minus 6. Okay. So answer is log x is log 6. So first is to plot the function, right? That's what we want to plot. Yeah. So this is the function exponential x minus 6. So this is increasing function with x is going like this. So my root is here. Okay. Now these are really plotted using Python. So my solution lies between 1 and 3. Right. I mean at 3 my function is positive, and at 1 my function is negative. So I call this XL and this is XR, and I iterate. Okay. So my first value is 3, the second value is 1. Now take the average of the two, which is 2.0, then average of 2 is to the right of the root. So I take 1 and 2 and average of that, which is 1.5. Well, yeah. So what is this here? 2 is here again. So this is 1.5. No, what I'm doing here? This 2 and 1 should be 1.5. 2 and 1, 1.5. Something is 3 plus 1 is 2. So slightly above 1.5. There's something is okay. I guess it's converging. Okay, I mean this is exactly from the data it is taken, but I think there's some bit of error in this plotting. Okay, so it finally goes to log 6, which is 1.79. Okay, my answer is 1.79 after some steps. So we need to see convergence, which is I'm going to put a tolerance. It's called tolerance. Okay, so we need to check always my how close I'm to the root. So let's look at the code. So my epsilon is 0.001. Okay, that's what I'm choosing, and I'm doing well. I need to make a bound. I mean, if I sometimes we may not converge in 1,000 steps or 10,000 steps. So it's good idea to keep a bound. Okay? So I'll say, well, I will maximum 10 iteration. And it turns out for this, we converge in 10 iteration. So I define an X array. So my X0 is 3 and X1 is 1. So this is to the right, XR, and this XL. Now I iterate it from 2 to n minus 1, right? So this will be X2. Now I compute the mid, which is I minus 2 minus I minus 1, which is okay, which is potential xi. Okay, so it is xi. So whether it should be replacing xi minus 2 or xi minus 1. Okay, so that's what we need to see. We should always keep 2 points, one to the left and one to the right. Now, if mid minus xi minus 1, so my new value, which is xi minus previous value xi minus 1, mod is less than epsilon. Okay, so so that is a measure. I don't know x star. Okay, in general, x star is well. If I know x star, then I don't need to do all this. So I don't know x star. So I say, well, I look at the two values, and if the error is sorry, no, if the difference is less than epsilon, then I would say I'll stop the iteration. So that's what is a condition for stopping the iteration. Put this modulus, mod. So less than epsilon, then I say xi equal to mid and break. I stop. Now, I need to have two values, one to the right, one to the left. Now, so this is how we do it. Xi minus 2, compute the function at that value, and f mid. If the product is greater than 0, okay, that means both of them have same sign. I minus 2 and f mid is the same sign. Okay, that means they are in the same side, both negative or both positive. Okay, that means I should replace I minus 2 by x mid, by mid. Okay, so xi becomes mid. So my two values will be xi minus 1 and xi, two FCs. Else, if they are two, if this is less than 0, that means they are in the opposite sides. So I need to retain xi minus 2, and okay, so xi minus 2 becomes xi minus 1. Okay, I just replace xi minus 1 by xi minus 2, and xi becomes mid. Mid is basically becomes xi. Okay, so this makes sure that xi minus 1 is one side and xi is in the other side. Okay, and we keep iterating it until this condition is satisfied, or n is 10. N is that max value. Okay, and we print mid each time in the loop. So print mid. Okay, so that's what is done there. There's a slight bug, I think, in the plot, but yeah. Okay, now, so this solution always converges. Okay, I mean, I showed you that it will converge. Okay, now a tricky function for which also the solution converges is this function, which I'm going to show you. Newton-Raphson does not work for this. So let's see how this function looks like and where is the root. So this is a function, is cube root of x. It is like that, and so the solution is that x equal to 0. Okay, so I take one value at minus 2. Well, is right now it is minus 0.5, and other one is at here. Okay, so I take two values, one to the left and one to the right, and you can quickly see that it converges to 0. Okay, so midpoint method or bisection method always converges.